Hello, this is Mr. Stansbury. I'm going to take you through the notes on series. At the end of this, you should be able to say, I can use sigma notation to find the sum of a series given several terms and vice versa. Okay, so first things first. A series is the sum of the terms in a sequence. So we're going to take all the terms of a sequence, add them all up, and get a total. Okay, a finite series has a first and a last term, and will therefore always be some kind of finite real number. So like, for example, if the series was 3, 7, 11, 15, and 19, this is going to give us an actual finite number. Okay, an infinite sequence has a beginning but no end. So like 3, 7, 11, 15, 19, ... meaning it goes on forever and ever. In many cases, the sum of an infinite sequence cannot be calculated, but in some cases, it does actually converge. It ends up getting closer and closer to a finite number. Okay, so we'll look at some cases like that. All right, the sum of terms, u sub 1, first term, u sub 2, second term, u sub 3, so forth and so on, all the way up to u sub n, which u sub n in this case is the last term, can be written using sigma notation or summation notation. This symbol here, this little funny looking E, is sigma, okay, and that's why it's called sigma notation. Okay. We write u1 plus u2 plus u3, so forth and so on, all the way up to un as this here. We got our little sigma notation here, k equals 1 on the bottom and n on the top, and then we've got our u sub k out here. Okay, so this reads as the sum of all numbers of the form u sub k, where k equals 1, 2, 3, all the way up to whatever n ends up being. Okay, so that n is going to be the last term in the sequence. All right, for example, here's our little sigma notation. The k is our index of summation, it's called, and that equals 1. So 1 is going to be the first value of n. So when we go through and figure this the series out, then what we would do is we plug in 1 for n first, and then we plug in 2, 3, 4, 5, all the way up, and our last term is going to be 7, the last value of n. Okay? So if we were going to do this here, this is going to look like this. Plug 1 in for n, and that's going to be, let's see here, that's going to be 3, right? And then we're going to plug 2 in, and again, we're going to add these all together. So instead of putting a comma, I'm going to put plus. So then we put a 2 in. 3 times 2 is 6. That's the second term. So we even do this first, second, third. So the next number is 9. We're keep multiplying by 3. And then 12, 15. So that's the fourth, fifth. And then 18, sixth. And then 21 is going to be the last one. So this all here is saying, what does this all equal? Okay, let's take a look at example 22 here. Consider the sequence 3, 7, 11, and 15, and so forth and so on. Write down an expression for s of n, and then find s of n for n equals 1, 2, 3, 4, and 5. So this is where we're going to use our good old summation notation here. Okay, and on the bottom, we're going to be k equals 1, because we're going to start with the first term, and then we're going to go all the way up to whichever term, 1, 2, 3, 4, and 5, and that's what n equals, so we would put n up here. And then what we're going to do in here is find our general term in here. So what we'll do is we'll start with u sub n, our formula, equals u1 plus n minus 1 times d, right? So we take u sub n. Our first term in here is 3, n minus 1, and then our d, our common difference, 3 plus 4 is 7, plus 4 is 11, plus 4 is 15, so our common difference is 4. And now we're just going to want to simplify this thing. So we got u sub n equals 3 plus 4n minus 4. So our general term here is going to be 4n. 3 minus 4 is negative 1, so we're going to do 4n minus 1, and this is our expression for s of n. Okay? Now, when we're finding S of n for n equals 1, 2, 3, 4, and 5, really what we're doing is so S of 1, so finding the sum of the first one term is just going to be 3. S of 2, the sum of the first two terms is going to be 3 plus 7. S of 3 is going to be 3 plus 7 plus 11. S of 4 is going to be 3 plus 7 plus 11 plus 15. And S of 5, 3 plus 7 plus 11 plus 15 plus 4 more than 15 would be 19. Okay, and we're really just going to go through and add up all these numbers and together and off you go. Okay, so like S of 1, just the first term is obviously just going to equal 3. 3 plus 7 is going to give us 10. And we can go through and keep adding stuff in there, and it's not too bad. Where it gets a little trickier is when this n gets up to be a bigger and bigger number, or this 4n minus 1 is a more and more difficult equation. So there's actually a way that we can do this on our handy-dandy graphing calculator. Okay, and that's to go into our summation notation. And now there's a couple ways to do that on here. Probably the easiest way, the most intuitive way, is to push the math button, and like where we find our cube roots and our x roots and all that kind of good stuff. If you scroll down to 0, it's summation, E sub, and it's got the little parentheses here. That's what we want, because we push that, and look, here's our little summation notation. We just fill in the blanks, and it will help us figure it out. Okay, so that's one way to get there. Another way to get there, which is faster but not quite as intuitive, is you do alpha and then window, and it will give us a bunch of different options here, and we'd want the second one, summation, here. But either way, it gives you the exact same thing. So whichever way is easier for you, you go ahead and pick that. But we're going to now fill in this info here. So we've got k equals 1. We don't, like, the variable that we're going to use with this graphing calculator is always going to be x. So we're just going to put x in there. And then it goes over to this here, and we're going to start with 1. Okay, now, super important on this, don't push enter, because it'll give you an error if you do. To go to the next thing, you want to push the arrow so that you can get there. And then really we don't have anything to fill in for this. Let's do this. Let's just do the second one, because we know that for sure that equals 10. So let's say 1 to 2. So it's going to add the first two together of this sequence here, which is described as 4n or 4x minus 1. Okay, so now that we have that, we push enter, and look at there. It gives us 10. Okay, again, where this gets more and more handy is when you get to bigger and bigger numbers. So let's also do this for 5. Now, instead of going back and re-entering this whole thing, I'm going to just arrow up until I've highlighted my original equation, and I push enter, and it's going to bring that equation back for me, and now I can go back and just edit that equation. So all I'm going to do is change that 2 to a 5 and push enter, and it tells me that this is going to add up to 55 right here. Okay, and just to double check or to show that it works, 3 plus 7 is 10, plus 11 is 21, plus 15 is 36, plus 19 more gives us 55. So then we know we ended up getting the right answer there. Okay? All right, that's all we have for the notes on series. If you have any questions on this, please feel free to ask in class. Thanks.